Okay, so what do you do when you see a polynomial and it is actually already in factored form? How do you figure out what's the degree and the leading coefficient and what's going to happen at infinity and at negative infinity? Now, one thing I want you to remember that this is going to be completely different from the case when a polynomial is not factored. So if it's something like negative 2x cubed plus 5x minus 3, the only thing that matters is this guy right here. Okay? That's the only thing that matters. However, if it's factored, students get very confused. What do I do? Okay, so let's take a look at it. First of all, what you should do is discard the other terms. The only terms that matter in each parentheses, okay, are the highest power terms. X is power 1, 4 is power 0. Which one is more important? Power 1. Okay, so you go ahead and just cross out the other one. Same thing here. X is more important than negative 3. Cross it out. Then what you do is your leading coefficient is the product of all the leading terms. Okay, so here we've got negative 2. The other ones are just 1 and 1 in front, right? So that's just going to be negative 2. So this is negative 2. The degree is going to be the sum because this is going to be x squared multiplied by x multiplied by x. This is x to the power 1. This is also x to the power 1. If you add them up, you get 4. Okay, that's your degree. Now, how do I determine, based on what I already classified, what's going to be the behavior at negative infinity and positive infinity? The first thing you ask yourself is the degree even or odd? Okay, so here the degree is even, right? 2, 4, 6, 8, so on. If it's even, the two answers over here are going to be the same. Either both positive infinity or both negative infinity. How do I know what is going to happen? I have to look at the sign of the leading coefficient. Because the sign is negative, right? That means both will be negative. Negative infinity, negative infinity. Okay? Now let's look at the next example. Again, what matters in each parenthesis, in each set of parentheses, is the leading term. X is more important than 1. You cross it out. Now, when I say more important, it's only more important for large x values, which is what you're looking at here. And this one doesn't matter, this one doesn't matter. Next, add the powers. So you've got x, 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 right? This x, this x, this x. Now, this is x to the power 1, power 1, power 1. What's the total? 3. That means that the degree is going to be 3. What's the leading coefficient? Well, I guess that would be this number right here because in front of the x's there are no other numbers. So that just means that the leading coefficient is 0.9. All that matters here is degree, even or odd. Okay, this is odd because it's 3. And then leading coefficient is positive because it's 0.9. Okay, how do I figure it out what's going to happen at negative infinity and at infinity? Remember how I said even, always the same. Either both pluses or both minuses. Odd, always not the same. Either one negative, one positive, or positive, negative, okay? Cannot be the same. How do I know what's going to happen? I have to look at the leading coefficient. Because it's a plus, then it's going to be mirroring the x. So if x goes to negative infinity, the function will also go to negative infinity. If x goes to positive infinity, it's going to mirror the exact same thing. Now, if the leading coefficient was negative, these two would have switched places, okay? But again, remember, even, same behavior on the ends, odd, opposite behavior on the ends, and it depends on the leading coefficient sign, if both are pluses, both minuses, or minus plus, plus minus, okay? Those are your cases.